Notation and terminology. As you recall from the previous section, we started exploring functions and understood them as a specific kind of relationship between different sets of elements. So let's move on to our next topic, notation and terminology. Now, to really work with functions, to discuss them, analyze them, and solve problems involving them, we need a precise way to talk about them. This slide marks a shift from the conceptual understanding of what a function is to how we represent and discuss it mathematically. We're going to dive into the specific symbols and words that mathematicians use when working with functions. And trust me, getting comfortable with these terms isn't just about memorizing definitions. It's absolutely crucial for clear communication. If you can't accurately describe a function, it's going to be very difficult to explain your reasoning or understand what others are doing. Plus, it's essential for successfully tackling function-related problems. So, let's build a solid foundation by understanding the language of functions. In the following slides, we will break down each component of this notation and terminology step by step. Understanding the notation. So now that we've established what a function is, a special relationship between sets, let's talk about how we write about them mathematically. This slide introduces the notation we use to clearly define and communicate about functions. We use a specific way to represent a function, and the general form looks like this. f:(b). Let me break that down for you. First, f, that simply represents the name of the function. Just like we give variables names, we give functions names too. You'll often see functions named f, but you could use any letter or symbol you like. G and h are also very common. It's just a label to help us refer to that specific relationship. Next, we have e. This represents the domain of the function. Now, remember from the previous slides, the domain is the set of all possible inputs to the function. Think of it as the set of things you are allowed to put into the function. It defines what the function can operate on. Then we have b. This is the codomain of the function. The codomain is the set of all possible outputs the function could produce. It's important to note that the codomain doesn't necessarily mean the function will produce every single element within it. It just means those are all the potential values the output could be. We'll see the difference between the codomain and what actually does come out, which is called the range, on the next few slides. Finally, the arrow that's read as maps to. It signifies that the function f takes elements from set A, the domain, and maps them, or transforms them, into elements in set B, the codomain. So it shows the direction of the relationship, from input to potential output. So putting it all together, f:(b) tells us we have a function named f that takes inputs from the set A and produces outputs that could be found within the set B. This notation is fundamental, so make sure you're comfortable with it, as we'll be using it throughout our study of functions. Key terms explained. So let's move on to slide 3. As we discussed on the previous slides, we've already touched upon some important ideas about functions. Now, we're going to formally define those key terms and introduce one more crucial concept. Let's start with input. An input is simply an element taken from the domain, remember. The domain is the set of all allowable inputs to our function. We feed this input into the function, and the function then does something with it. Next is output. The output is the element you get from the codomain after applying the function to a specific input. So, if you put something into the function, the output is what comes out. We commonly write this as f of x, which means the value of the function f when the input is x. Think of f of x as the result you get when you substitute x into the function. Now, let's quickly revisit domain. As we've already established, the domain is the complete set of all possible inputs that the function can accept. It's everything you're allowed to put into the function. Similarly, the codomain is the complete set of all possible outputs that the function could potentially produce. It's important to remember that the function doesn't have to produce every element in the codomain, but all its outputs will definitely come from this set. Finally, we have range. This is where things can get a little tricky. The range is the set of actual outputs that the function does produce when you use all the elements from the domain. It's a subset of the codomain, meaning everything in the range is also in the codomain, but not necessarily the other way around. Think of it like this. The codomain is everything the function could output, and the range is everything it actually outputs. We'll see this distinction between codomain and range illustrated with examples on the next few slides, so it's important to keep this difference clear in your mind. Understanding the range is key to fully grasping how a function behaves. Example, illustrating the terms. Let's move on to an example to really solidify our understanding of domain, codomain, and range. As we discussed in the previous slides, these concepts are vital when working with functions. Now, on this slide, we're going to consider a function, let's call it f, that simply squares a number. So it takes a number and multiplies it by itself. We're going to define our domain, which is the set of all possible inputs, as A, and it contains the numbers 1, 2, and 3. I'm representing this set using curly braces, 1, 2, 3. Remember, the domain is what we're allowed to put into the function. Next, we define the codomain, which is the set of all possible outputs that the function could produce, as B. This set contains the numbers 1, 4, 9, and 16. Again, this is represented with curly braces, 1, 4, 9, 16. It's important to remember the codomain isn't necessarily what the function will output, just what it could output. Now we define the function f itself. We write it as f of x equals x squared. This means that for any input x, the function f will multiply x by itself. Let's look at some examples. If we input 1 into the function, so f of 1, we get 1 squared, which is 1. Similarly, if we input 2, so f of 2, we get 2 squared, which is 4. And if we input 3, so f of 3, we get 3 squared, which is 9. These are the actual outputs we get from our function for the given inputs. Now let's recap the domain and codomain. The domain, is still 1, 2, and 3. The codomain, b, remains 1, 4, 9, and 16. Finally, let's determine the range. The range is the set of actual outputs we obtained. Looking at our calculations, the outputs were 1, 4, and 9. Therefore, the range is 1, 4, and 9. Notice something important. 16 is in the codomain, but it's not in the range. This is because no matter what number we chose from our domain, 1, 2, or 3, squaring it didn't give us 16. This highlights the key difference between the codomain and the range. The codomain is everything the function could output, while the range is everything it actually outputs. We'll build on this understanding in the next slide, so make sure you've grasped the difference between these terms before we move forward. Another example. Let's move on to another example to really solidify our understanding of domain, codomain, and range. Here we have a function named g. We're defining this function as mapping from a set A to a set B. Now, remember what that notation means, g. A to B, we read that as g maps from A to B. Let's look at what these sets actually are. Set A contains the elements A, B, and C. So, A is equal to the set containing A, B, and C, and set B contains the numbers 10, 20, 30, and 40. So, B is equal to the set containing 10, 20, 30, and 40. Now we define our function g. We're told that g applied to A, that is, g of A is equal to 10. Similarly, g applied to B, or g of B, is equal to 20. And finally, g applied to C, or g of C, is equal to 30. This tells us exactly what the function does to each element in its domain. Let's identify the key terms now. The domain, as you recall, is the set of all possible inputs. In this case, that's set A, which is a B, and C, the codomain, is the set of all possible outputs, and that's set B, which is 10, 20, 30, and 40. Finally, let's determine the range. The range is the set of actual outputs that the function produces. Looking at our function definition, we see that when we input A, we get 10 as the output. When we input B, we get 20. And when we input C, we get 30. Therefore, the range is the set containing 10, 20, and 30. Notice something important. The range, 10, 20, and 30, is a subset of the codomain, 10, 20, 30, and 40. The The codomain includes 40, but 40 never appears as an output of our function g. This example, like the previous one, reinforces the crucial distinction between what could come out, the codomain, and what actually comes out, the range. We'll continue to emphasize this difference as we move forward, as it's a common area where students make mistakes. Key takeaways. Let's recap what we've learned about function notation and terminology. This slide summarizes the key takeaways, which are really important as we move forward. First point, the notation f:(b) is fundamental for describing functions. What this means is, remember that way we write a function, f:(b), this isn't just a fancy symbol. It's the core of how we communicate what a function does. F is the name of the function, A represents the domain, and B represents the codomain, and the arrow shows the mapping from one to the other. Getting comfortable with this notation will make everything else much easier. Next, and this is where students often stumble, understanding the difference between the codomain and the range is crucial. The codomain is all possible outputs, while the range is the set of actual outputs. Think of it this way. The codomain is like a container that could hold all the possible results of the function. But the range is what's actually inside that container, the values the function really produces when you give it inputs from the domain. We saw this in our examples, where the codomain had some numbers that weren't actually produced by the function, and those weren't in the range. Finally, functions map inputs from the domain to outputs in the codomain. This is the essence of what a function does. It takes something from the input set, the domain, and transforms it into something in the output set, the codomain. It's like a machine. You put something in, and it spits something else out. Keep these 3 points in mind, because we'll be building on them as we tackle more complex function problems. And remember, if you're ever unsure about domain, codomain, or range, go back and review those definitions. The next slide will highlight some common mistakes to avoid, so let's make sure we're solid on these fundamentals first. Common mistakes. Let's move on to the final slide, which highlights some common pitfalls students often encounter when working with functions. This is really important, so pay close attention. This slide focuses on common mistakes, and it's good to be aware of these before you get stuck on a problem. The first, and probably most frequent error, is getting the domain and codomain mixed up. Now, remember from our earlier discussion, and looking back at those examples on slides 2, 4, and 5, the domain is the set of all possible inputs. Think of it like this. It's the set of things you put into the function to get an answer. The codomain, on the other hand, is the set of all possible outputs the function could produce. It's everything that might come out. It's crucial to remember the could part. The codomain isn't necessarily what does come out, just what can come out. So, to reiterate, the domain is what you put in, and the codomain is what could come out. Now, the second common mistake is misidentifying the range. We define the range as the set of actual outputs that the function produces when you use all the inputs from the domain. It's easy to fall into the trap of thinking the range is the same as the codomain, but that's not always true. Remember, the codomain includes everything that could be an output, while the range only includes what actually is an output. So, when determining the range, you need to carefully consider what the function actually produces when you apply it to every element in the domain. Don't just list the codomain, find the specific outputs. Understanding these distinctions will save you a lot of trouble as we move forward with more complex function concepts. Make sure you review these points, and feel free to go back and revisit the examples on the previous slides if you need a refresher.